What's up, folks? Welcome back to the channel. In this video, I want to talk about agents. So I want to do a little introduction, and this is part of a presentation that I've been doing for O'Reilly Media. I'm an instructor there, and I do live trainings about building stuff with LangChain, with agents, with large language models, prompt engineering, etc. What I would like to do now is just go through a basic introduction on agents and some cool, interesting things you can do using LangChain to build really powerful and interesting agents. So let's get started. So this is my presentation. We're just going to go through. So I'm a machine learning engineer. I'm also an instructor at O'Reilly, and I'm very curious about all things intelligence. Now, regarding agents, we're going to be looking at agents as the combination of thought and action. And then we're going to be talking about a definition, and we're going to talk about tools. We're going to talk about this idea of agents in 3 complexity levels, and we're going to talk quickly about the OpenAI's function API. Then we're going to talk about LangChain as a framework, and then building agents with LangChain. So what are the things that are important to think about? And then, not in this video, but in the next video, I'm going to be sharing some of the demos that I've done for this particular presentation that I think could be really cool. So we're going to skip the demos today, but we're going to do demos at the for the next, I think, 2 to 3 videos. And I also have a bunch of other videos where you can look at how to build agents with LangChain, etc. So let's get started. Now, what is an agent? I like to think about in simple terms about this idea of combining thoughts and action. What I mean by that is, how do we do anything, right? Now, we think and we act, kind of obviously. And one example of that is, and I use this example in my presentation, the decision-making process for like attending a live training, for example, right? You might think, I want to learn about agents, and then you might say, okay, so I'll go online and you research cool platforms where you can learn about agents. And then you think, okay, so O'Reilly has some really interesting courses in live trainings. And then you take an action, which is looking at O'Reilly courses. And then you think, all right, live trainings by instructor Lucas are awesome. No bias at all. And maybe you schedule live training with me. Look at that. Now, jokes aside, the idea of thoughts here is very reductionist. This is a very simplistic definition, right? It's all about thinking what to do and then planning ahead, meaning prioritizing and ordering over the things that you're going to do. And action in this context means the usage of tools like searching, browsing the internet, etc. Right? So, in essence, what is an agent? Well, an agent is nothing more than the combination of an LLM plus some tools. Now, this is a very simplistic definition of an agent, and it is in the context of the current surge of applications for large language models. So, obviously, an agent can be defined in other ways. If you're new to if you're new to large language, if you're new to AI, if you have no idea what I'm talking about, we're not going to go into details about large language models. I do this in other presentations, but an LLM is essentially a model that can predict the next word or the next sentence based on some previous context, right? It will calculate the likelihood of the next word, and it will output some completion that makes sense for what it has seen in the past, which we call context, right? So in this case, I'm doing a very silly example. Maybe a model will take in a phrase like "I love eating," and the output of that LLM will be pancakes. That would be true for me. I don't know if that would be true for you. Now, a tool is just anything that allows this model, this reasoning engine, this LLM, to perform actions in the real world. Like, for example, a pancake maker will allow you to make pancakes in the real world. Ha ha ha. I know I'm hilarious. One of the first papers I remember reading regarding this idea of combining LLMs with tools is a paper called Toolfarmer, pretty cool paper. And in it, they show that LLMs could teach themselves how to properly call external tools. And this is an example where to perform some completion on some text, the LLM understands that it needs to call some tool, and then it calls this QA tool in order to get a response. And that response gets fed back into the text, gets fed back into the completion, etc. And then we have a response, right? And they show examples with calculator, with Q&A, and I say and Wikipedia search, right? So tools in this context are all Python functions, so Python code that the model can decide to execute. And they set up a system that allows the LLM to make that decision, call the function. It doesn't call directly, right? It just outputs a string indicating that the function should be called, and then there's some hack around it so that that decision can be translated into an actual action that calls the tool and performs the action of like searching Wikipedia, calculating some math problem, etc. All right, cool. Now, another fundamental paper to understand agents that I think is paramount for the current useful applications that we have of agents today is a paper called React. And in this paper, where they discuss this idea of LLMs for reasoning and action, and essentially they discovered that you could prompt the models, prompt LLMs like ChatGPT, to interleave thoughts, actions, and observations in such a way that when the model is trying to solve a problem, the LLM is trying to solve a problem, like for example, here, it begins to tackle the problem by saying, I need to search X, right? It's saying it right here. I need to search Apple Remote and find the program, etc. So then it takes an action. The action is the search, which is right here. And then there's an observation from that action, which is the remote is a control introduced in ta. So we discovered that from the search. And it goes on and on, interleaving thoughts, actions, and observations in that manner. So all of that to say, these two papers, I think obviously there are many, many more papers, right? And we're not going to tackle the papers because this is not a technical introduction to what agents are. This is just to give an idea of when you hear about agents out there, what are we talking about? What are agents? How do they connect to LLMs? And what is interesting about them, right? Because they're getting very popular. Like this is a graph from a paper called "The Survey on Large Language Model-Based Autonomous Agents," and you can see that over the last 2 years, there's been a surge of papers about using LLM agents to do all sorts of stuff. And that's interesting because with the surge of ChatGPT and other LLMs that could actually do really, really useful stuff, they realized that if you put that as the reasoning engine in the center with access to tools and being able to manage, a bunch of stuff like, performing search, executing code, etc., you could have a really powerful AI that, has behavior that can perform actions and not only just output text, right? So there are many popular agent implementations. We're not going to go over like all of them. And some of one of it is Baby AGI, which is one of the first ones that did this thing of combining LLMs to tools, and they did a really interesting work in having these task prioritization, task execution, and task planning separated. You have these separate modules to do these things. So you have AutoGPT that does this long-running, open-ended goal pursuit. And this is one of the most, this is a famous repository that, has gotten a lot of popularity and can do some pretty cool stuff. You have also GPT Researcher, one of my favorites, and it was actually featured. Harrison Chase, the creator of LangChain, featured it in one of his videos about building a research assistant, and I kind of played around with it and read through the code. And GPT Researcher is one that I really like because it's all about combining an LLM with tools that allow the LLM to perform research. So you end up with this really cool research assistant that can do some pretty cool stuff. You also have OpenGPT, which is the open source customizable agents that are supposed to be the open source version of custom GPTs, which are tools today that we have access to by OpenAI that allow you to customize your own ChatGPT to a particular purpose. And this is a really cool implementation as well. Now, Anders Karpathy mentioned agents, and I also think that every time Anders Karpathy says anything, I always pay attention. And he makes a really interesting point in this video that I definitely recommend you check it out about why you should, play around with agents. I think that in this image it's not showing very well, but I put a link in the description. So let's talk about agents in 3 levels of complexity. Now, when I talk about complexity here, I mean complexity of, implementation in a very raw sense, because I think it's cool to think about how you can connect a model that only knows to read and output text to tools that perform actions in the real world. And it's actually not that, bizarrely complicated, the way that that is set up. The thing that is complicated, is how you get to train a model to have amazing general performance across many tasks. Now, at the level one, this is a video I did before that has gotten a lot of popularity, and I'm really happy about that. And I kind of integrated it into my presentation about agents because I think it's a very interesting and intuitive way to understand how they work. Now, level one is about putting Python functions, right, code inside of the prompt that you send to an LLM, right? So that was inspired by Toolformer. I mean, I think there are papers before Toolformer. I'm not very sure. I might be wrong about that. If I am, please help me out in the comment section. However, what is the basic idea? The basic idea is that you might have some code like this, right? So I have some functions to create directories, to create files, to list files, right? And this is just the general way that this is how you call ChatGPT, right? And what we're going to do is we're going to put everything inside of a prompt like I'm doing here. So I have a description of a task, right? And it's saying create a folder called Lucas the Agent Master because, inside I'm 12 years old. Okay, so that's the task is create a folder called Lucas the Agent Master. And then the output is I call ChatGPT. However, when I call ChatGPT, I not only give the task description, right in my prompt, I add that the model has access to these functions. And I actually put the functions there with some quick, simple descriptions of what these functions do. And I add your output should be the first function to be executed to complete the task. And the output should only be the Python function call, nothing else, right? I kind of try to help the model to see if the model can learn to just call that one function. And when you run this, you'll see that you get actually a good result. And I have a repo, I think, with this implementation. I'll put that link in the description. So the model can call the right function to execute the task, which is pretty cool, right? Now, all we need now would be to find a way to execute the function. So you can use exec from Python, which is a built-in method that allows you to execute functions inside of a terminal, right? And you can have something that looks like this, exec, and this should not be called model. I apologize. This should be just exec. It should be just exec output. I have to change that, right? And what happens is that you actually get to create the folder. Is that before I had it as a class, so the model dot was just to execute a method of a class. So the model makes outputs the correct text to call the right function with the right parameter, etc. And what you're doing is just setting up a hack using Python's exec method to execute what that function call was, right? Now, some of the limitations of that are that probabilistic outputs make function calls unreliable, which is annoying. You have a need for structured ways to prepare the inputs of the function calls. And putting entire functions inside text prompts is not exactly amazing, right? It's clunky, it's not scalable, it's weird. So what should you do? Well, you could use OpenAI functions, for example. Usually I would do a Q&A, but I'm doing this video for YouTube, so no Q&A right now. However, ask anything on the comment section. I read all the comments, and I always try to answer everyone that asks relevant questions. The OpenAI function calling is really cool, right? They trained the model to be able to be calling Python functions. So they trained the model to be good at that. And what they did is they connected models to outside tools in a standard way. And the steps to do that, and you can check that out in the docs for the OpenAI function calling. I'm just going to repeat it here. So you can call the model with a query and a set of functions that are defined in the functions parameter. So you have a standard way to define the functions for the model. And then you choose to call one or more. And if the content will be stringified JSON object that can adhere to a custom schema. And you parse the string into JSON in your code, and you call the function with the provided arguments if they exist. And then you call the model again by appending the function response as a new message. You let the model summarize results back to the user. Let's take a look at that in practice, right? So you would have a function like create directory, right? So you have this function. So here is where we define the function for the model. essentially we're saying, okay, so this is a function, this is the name, this is what it does, and then properties, it has this parameter called director name of type string with this description of the parameter in this case, right? And then you put it inside of a list, right? Because you could have more than one function. Then you write up a little function called run terminal task. This is essentially, I just made modifications for a simpler example, but it's just from the actual OpenAI function call in documentation, which I'm going to put in the description. So essentially what you do is that you have this messages parameter here, which is the traditional messages parameter that you would put in the ChatGPT API, right? You have the function, you have the functions that you created, right? So the tool is right here, the tool to create directory. And then you call the model and you set tools to tools, tool choice to automatic, and then you get a response. And then you check if there were tool calls in the response, right? If a tool was called during the response, the model identifier had to call a tool and then it called the tool, right? If that happened, you go to step 3. And the step 3 is to parse and execute the function. So what you do is, okay, so you have a set of available functions, right? And then you loop over the tool calls because there might be more than one tool call. And you say, okay, function name, tool call, function name, and then you get the function, you load the arguments, you call the function. This is the call to the function, calling the function, okay? And then you append the response to the messages parameter, right? And you append it in a standard way. So you append a dictionary with the keys tool call ID, the role. In this case, the role is not user, it's not system, it's not assistant, it's tool. And then the name of the function and the content of the response from calling that particular function, all right? And you summarize the results back to the user. So you do a second call to the model so that it can put everything together into a response, and then you send it as a response, right? Now, here I've done videos on OpenAI functions before, so check it out on my channel. And now let's talk about LangChain as the third level in this abstraction complexity layer that we're discussing. So how could we effectively perform tasks using agents? Well, in this really cool article by, I think it was Harrison Chase, I don't remember who wrote it, but it was from LangChain. And it's called OpenAI's Bet on a Cognitive Architecture. They actually discussed this really interesting idea that OpenAI's model with the Assistance API is actually making a bet on a specific type of cognitive architecture. And they discuss, why is that interesting, why that's the case, and different cognitive architectures, etc. Now, usually any agent that you have, and remember when we talk about agents, we're talking about LLMs-based tools, right? Involves this idea of you having some user, and let me change the color here. Yeah, so you have some user, and the user will call the LLM, right? The LLM can either send a response directly, or it can call some tool, right? Perform some action. When it performs an action, you have an observation from that performance of that action, right? And that everything gets fed back to the LLM. Now, that goes in a loop until you have some response. When you get the response, then you send the output. Oh, sorry. Now, that's the basic agent loop, all right? So, a really interesting point they make in this blog post is that good agents are routers. They know how to route stuff well to different things. So, useful agents implement a routing type of architecture than an actual agent architecture. So that's more in practice, right? They make this point on that same blog post that I was discussing. And I kind of agree because my experience building things that are actually useful usually involves building chains where, the LLM has a smaller participation because there's an uncertainty regarding the output from the LLM. So it's more that rather than just let it decide everything, do everything, right? So LangChain is a really cool framework where you can implement these routing procedures. Yeah, this should say routing procedures. Let me just change that. Routing procedures. There we go. So let's see how that works. So LangChain, if you're not familiar with LangChain, LangChain is a framework for building context-aware reasoning applications. Essentially, it's a framework to build powerful applications that are powered by large language models. And the main features are components, which are these tools and integrations that you can use to work with large language models, and you have off-the-shelf chains. You have off-the-shelf building blocks that are pre-built that allow you to do tasks that are, common that you do every day. Text summarization, talking to a PDF, like asking documents for stuff. Something called RAG, which we're not going to cover in detail in this presentation, but it's something that we can discuss in the next video. Now, what are the core elements of LangChain? Well, you have the model, you have the prompt, and the output parser. The model is nothing more than just an abstraction over the LLM API, like the ChatGPT API, right? So this is an example on how to call the chat OpenAI. Right now, they changed the import because they did some, in the next version. So this is actually LangChain OpenAI, because now they separated the modules. Honestly, I would like LangChain to make stuff a little bit more simpler in terms of the changes in the imports and things of that sort. But and this code was a bit outdated in that sense, just because they changed it in the last version. So now this is deprecated, but whatever. This is how you call chat OpenAI. So you interact with chat OpenAI, you give the OpenAI API key, you set the model you want, and then you can use it. And actually now this is also deprecated. You would call invoke. But whatever. All we're saying here is that the model is an abstraction over calling some provider of an LLM. Okay. Now, another one is prompt templates or prompts, right? And that's nothing more than just an abstraction over text prompts that you send to an LLM. So essentially, what LangChain is doing is they're taking everything that's related to interacting with LLMs and making, infrastructure around it, transforming it to objects that you have more control over. Right? So you want to have variables over all the aspects around working with large language models. Now, here is an example of using chat prompt template directly from a prompt. So this would be the prompt, right? However, the new thing here is that you can, and this is actually not showing here, it should have said this concept. Yeah. This is the end of this prompt. So show me 5 examples of this concept. And now this is a variable. And the power is right there, right? So it's dynamic, okay? Meaning you can call this prompt now with different names for the particular concept, right? Just like you would with just basic formatting of a string. The difference with using this prompt template is that you can put it inside of a bigger, more complex chain of building blocks to do interesting stuff, right? It becomes kind of a Lego piece in a bigger Lego structure that's, you're building a house, you're building a bridge, or whatever you're doing with Lego. All right. So the last one is output parser, and that's just parsing outputs of an LLM. An LLM will give you an output like, the answer to your question is 5, but you just want the number 5. So why do I have to have all that text around it, right? You need to parse the output of the LLM. And there are many interesting ways to do that. And output parser is a big thing in LLMs. And now LangChain is very well integrated with Pydantic, which is a Python data validation library, which is super powerful and allows for you to have something called structured prompts, or it allows you to have control over what comes out of an LLM and comes into an LLM, and it's pretty cool, pretty interesting. So output parser is all about parsing the output of an LLM, all right? Now, next thing is LCL, which is LangChain's expression language to put everything together. And essentially that's using the pipe symbol, which is like the Unix pipe symbol that you use in the terminal, if you use the terminal, to combine stuff together, okay? So it's an interface that leverages the symbol to compose components, and you have this type of structure here, right? So this is a basic example where I have the chat OpenAI, the template, string output parser that parses the output of a model into a string, because usually that would come as a AI message object, if I'm not mistaken. So if you give the string output parser, you get the string. And now you have model prompt parser, and boom, when you put it all together, this is called a chain. This is a building block, okay? So this is a building block. It's our Lego piece. This is where we start building stuff. That's interesting. I don't know why I'm trying to draw Lego pieces here. I clearly don't know how to draw. And the only interesting thing that you have to pay attention here is that when you invoke this chain, this building block, you have to give the variable that was set in the prompt template. So in this prompt template, name 5 concepts related to this concept. The variable here was concept. So that's why it says concept over here, all right? That's all. Now, let's talk about the agent loop. So I said before that this is the loop, right? You have the user, you send something to the model. It can either go output or you go action. From action observation, it goes back. You can go into this loop again, and you can do that, in a sequence until you have an answer. When you have an answer, boom, you go to the output, right? That's the loop. So some key components for setting up these loops using LangChain are a schema. And what is a schema? So LangChain gives a bunch of abstractions to allow for ease to use. But for that use to be easy, you have to have structured ways to interact the different components. So that's what they call schema. I don't know if that's a good definition, but that's my definition. And you have things like agent action, for example. Agent action is just an object that represents that an action that an agent should take. Okay. Agent finish, it's just the final result that you would get to the user. All right. And intermediate steps is just previous actions and outputs for the current agent run. So essentially, when an agent's trying to solve a problem, right? It might do a bunch of calls to an LLM, call tools, etc. Right? So you have a bunch of intermediary work that you have to store somewhere. So intermediate steps is where you store all of that. And then you have the agent, and that's just the chain that's responsible for deciding the next step that's powered by a language model. Okay. So what are the inputs to the agent? So you have this key value mapping, and you have two things that you need to have there, right? You have the intermediate steps, and in the output, you have to have either, you're always looking for either a next action or the final response. Now, LangChain is changing quite a bit. So this could have changed, but even if like something specific here changed, I think that the general idea here is that you have an LLM, right, which is in a loop with tools, okay, with calling tools or with just thinking about how to solve the problem, whatever. So you're in this loop, okay, until you have a response. When you have a response, you get out of the loop, and then I'm going to put here response, and you output, right? You give your output to the user, okay? So all of the stuff that happens before you give the final response is the intermediary work that we're talking about, okay? And then when you get the final response, you need a structured way to say, so agent action would be everything that's going on here, right? Everything is like, okay, so this is an action from the agent, meaning it's calling a tool, it's doing something, all right. And then agent finish here, okay? So it's how LangChain, it's where you can put in the loop to let the model, to let it know, to end the loop and then return an output, okay? So it's how you say it's over, okay? You need you need a stopping condition, but then you need a signal for that stopping condition. And we're talking about the loop, so we can look at in code and see what that looks like. So you might have, okay, so do this, right? Okay, so while the next action you have to take is not the agent finish, observe, and what is the observation? It's the output of running that particular next action, right? And that next action doesn't necessarily have to be a tool call, not sure right now, but the idea is you do the observation and then you evaluate what is the next action, right? So the next action might be, do this or do that, etc. First you have to fetch what the next action is, you return it, and then you go in a loop, right? So you set up the loop until you're done and you send the output. And it's good to have this kind of runtime because you can handle stuff like errors when calling the tools and logging information, logging how the model reasons about stuff. And LangChain is really cool because they're setting up infrastructure for deployment, obviously. And they have this tool, which I think is still in beta. It's called Langsmith, and essentially you can look at the intermediate steps and you can evaluate everything that's going on with the agent until it solves the problem. And you can, there's probably a bunch of stuff that's going to be built upon the next 6 months on how to be efficient at evaluating that a model is being efficient. So this is pretty cool. All right, tools and LangChain are awesome. Those are just functions that an agent can invoke. It's actually a little bit out of context, this part of the slide. I maybe should change that. But just for you all to know, a tool in LangChain, you have an input schema for the tool, you have a function to run, and it's very important for building a working agent. And LangChain provides you with toolkits. So it's like groups of tools for performing objectives, like GitHub Toolkit. I've played around with it because I've actually done a video on using Python's like sub-process to just call the actual terminal commands for Git, which obviously assumes that you have Git installed in your machine. And not only that, but it's not like the most reliable. This is based on something called PyGithub, which is like a package in Python for interacting with the GitHub interface. And it's great. What I like about LangChain is that LangChain is all about doing stuff. It's all about let's do stuff. And that's what I love about it. That's what I enjoy about it. I think that they have to do probably a better job on the coming months to make it more intuitive to use, because even for people that develop on it, I think that sometimes gets a bit confusing. Some of the ways that you're supposed to build stuff like agents and chains. However, what I do enjoy is that, and I follow them closely, is that they're all about doing, performing actions in the real world. So they're setting up integrations. That there's like a bunch of integrations. They're thinking about, okay, what's the easiest way for you to make an LLM useful? That's what I really enjoy about LangChain and why I trust that this is a framework that's going to be really paramount on the next years on, building powerful, useful tools that are, based off large language models. And yeah, they provide these toolkits, which is awesome. So yeah, these are some of the references for this presentation. I hope you liked it. If you like this video, don't forget to like and subscribe, and see you next time. Cheers.